3.5 variation of parameters. This is another technique that we're going to solve for high order differential equations. In the 3.4, this undetermined coefficients, we need to be careful when we're setting up the yp. So we have to look at y sub c first, see whether there's a repetition or not. If there is, then we need to make it higher order. That's what we did. For section 3.5 in the variation of parameters, we don't have to worry about that. So we're going to do the same thing as a y sub c, and finding y of p is going to be completely different. But this time, we don't have to worry about any repetition. It'll take care of it using this technique. So method of variation parameters used to find the yp. And those of you who watch the section 3.1, 3.2 videos, we talk about Wronskian. So we're going to use this Wronskian in this technique. So there are 5 different steps. The first step is the same thing that we've been doing it. Find the y sub c using Ox equation. Step number 2, we need to compute the w, w1, and w2. Those are the Wronskian. So w, we're going to have a y1 and y2. Second row, we're going to put y1 prime, y2 prime. Where do you get the y1 and y2? From yc. And then w1, the first column is going to be 0 and f of x. Where's the f of x? The right-hand side. So in 3.4, we look at the right side, f of x, and then we find the proper yp. But for here, just plug this f of x into the first column. And these are the determinants, so AD minus BC. W2, we're going to use that 0 and f of x in the second column. Then what do we need to do? We're going to let U1 prime equals to W1 over W. U2 prime equals to W2 over W. And you need to find U1 and U2 by taking integral for both sides. And then yp equals to u1 y1 plus u2 times y2. And then general solution again is y equals to yc plus yp. It's not going to be easy. It's complicated. But again, you are allowed to use any cheat sheet. So make sure you copy this down when you have a quiz or exam. Go through these steps. You are given y double prime minus 4y prime plus 4y equals x plus 1 e to the 2x. So step number 1, we need to find the Ox equation. M squared minus 4m plus 4 equals m minus 2, m minus 2 equals to 0. From here, we have m equals to 2 and m equals to 2. So we have to have a C1 e to the 2x and C2 e to the 2x. Well, they are the repetition, so we need to multiply x. So y sub c equals C1 e to the 2x plus C2x e to the 2x. Now in the undetermined coefficients technique from section 3.4, now we need to look at the right-hand side, and we need to let yp equals ax plus b e to the 2x. But we cannot do that because b e to the x is right there, x e to the x right there. So we need to have ax squared plus bx plus c. Well, bx and times e to the x, that's again the repetition. So if you are using undetermined coefficient technique, then yp has to be something like ax cubed plus bx squared times e to the 2x, so that there is no any repetition. So that's for section 3.4. Now in this section, section 3.5 variation parameters technique, we don't have to worry about it. We know y1 equals e to the 2x from yc, and y2 equals x e to the 2x and use those two to find Wronskian. For the w, we have y1 e to the 2x, y2 x e to the 2x, and the second row is going to be derivative of this guy. So 2 e to the 2x for the first column, and the second column, the first derivative second, which is e to the 2x, plus first the second derivative, that is the 2x e to the 2x, and then it's
determinant. So what we need to do, AD minus BC, which is e to the 2x, e to the 2x plus 2x e to the 2x, minus BC, x e to the 2x times 2 e to the 2x. That is e to the 4x plus 2x e to the 4x minus 2x e to the 4x. So this guy's cancel out. So we have e to the 4x only.
and then w1, we need to have 0 f of x in the first column. F of x is x plus 1 e to the 2x, and we keep the second column. And then AD, which is 0 minus BC, and that'll give us this. And similarly, W2, we put 0 and f of x in the second column, and AD minus BC, we end up getting this. We need to find U1 prime, that is W1 over W, and then you need to take the integral for both sides to get U1. Same thing, U2 prime is W2 over W, and then take the integral for both sides to get U2. Step number 4, find the YP. How? U1, Y1, U2, Y2. So we calculate the U1 and U2, and initially we have Y1 and Y2. So we multiply those, then we end up getting YP as this. Finally, we can find the general solution as Y equals to YC plus YP. This is our YC. This is our YP. You're given Y double prime plus Y equals to tangent X. Step number 1, we need to find YC. Find the X equation from here. That is M squared plus 1 equals to 0. No prime, no M. Keep telling you, no prime, no M. Is M equals to plus minus J. So our Y sub C equals to C1 cosine X plus C2 sine X. We have e to the alpha X times C1 cosine beta X plus C2 sine beta X, but there's no alpha in here, 0 plus minus J, and beta equals to 1, J 1. Step number 2, we need to find W, W1, and W2. W equals determinant of
y1 cosine x, y2 sine x, and the cosine x prime negative sine x prime cosine x, AD cosine square x minus BC sine x squared, which is 1.
W1, we need to put 0 and f of x, and f of x was tangent x. Then we have the second column, sine x and cosine x.
So AD, which is 0, minus BC sine x times tangent x, that is negative, that equals negative sine x times tangent is sine over cosine. So that is negative sine square x over cosine x.
Then our W2, the second column is now 0 and tangent x, and then first column, same as the W.
Then AD cosine x times the tangent x minus BC, which is 0. And that is cosine x tangent x equals to what? Sine x over cosine x. Therefore, it is just sine x.
Step number 3, U1 prime equals W1 over W. and u2 prime equals w2 over w. So u1 prime is w1 negative sine square x over cosine x over 1. W is 1, this problem. And the cheat sheet say if there is only sine square x, we can do that. And the cheat sheet in the first page, integration formulas 1, 2, 3, 4, fourth line from the top, we can do that. But because of the cosine x, we have to do integration by part. Or let's play with this a little bit. Sine square x plus cosine square x equals to 1 minus sine square x equals, if you move this guy to the right hand side, that is cosine square x minus 1. Minus sine square x equals to what? Cosine square x minus 1 over cosine x. That is cosine x minus 1 over cosine x, which is secant x. Let's say integral of the cosine, obviously we can do that. Integral of secant x is given, so it's much better. So now u1 equals integral of this guy. So cosine x to sine x minus secant x is the third line in the middle, ln secant x plus tangent x. And we have u2 is w2 sine x. So u2 then negative cosine x. So step number 4, yp equals to u1 y1 plus u2 y2. That's u1. And then y1 cosine x plus u2 negative cosine x, and then y2 sine x. And step number 5, c1 cosine x plus c2 sine x, that's the y sub c, plus yp minus cosine x sine x, and there cancel. So our final answer is y equals c1 cosine x plus c2 sine x minus ln secant x plus tangent x times cosine x.